In this section, we will continue looking at the graphs of quadratic functions. When our quadratic function is in this form, it is easy to determine the vertex and the axis of symmetry. What does it take to get our quadratic function in this form? And is there an alternative to getting our quadratic function in this form to determine this information? This slide discusses the two methods of finding the vertex and axis of symmetry. The first is to complete the square on the quadratic function. When the function is in this form, the vertex can be found very easily. I'm fairly certain we will prefer the second method. It will require us to memorize a little formula, but I bet we'll find this much easier. We are asked to collect a lot of information on this quadratic function. What we know is that the parabola opens up due to the positive leading coefficient. Let's complete the square on this quadratic function to determine the vertex and the axis of symmetry. These steps are similar to those that we discussed earlier in this chapter. The difference is that for the quadratic function, we will remain working on the right-hand side. We move the constant off to the side. We're not going to move it to the other side because with functions, we stay working on the right-hand side. Our leading coefficient is 1, therefore we are ready to make up that number that creates a perfect square trinomial. Referring to the middle coefficient, -4, we take half of it and square it. Since we're staying entirely on the right-hand side, we add 4 and then also subtract 4 so that we've only added 0. X squared minus 4x plus 4 is a perfect square trinomial. We factor this as well as add the 3 and -4. With this form, we are easily able to determine the vertex and axis of symmetry. We finish by finding the intercepts. Any x-intercepts can be found by setting y equal to 0. You may consider checking the value on the discriminant to see if there are any x-intercepts. Remember, if the discriminant is negative, there are no real zeros and therefore no x-intercepts. To find y-intercepts, we'll be setting x equal to 0. The discriminant is a positive value, therefore there are 2 x-intercepts. Also, with it being a perfect square, this says our quadratic will be factorable. We set y equal to 0, and to find these x-intercepts, factor. To find the y-intercept, we set x equal to 0, and when you replace x with 0, all the terms will drop out except for the constant. Therefore, the y-intercept is always the constant of the quadratic function. Here's our second example. We start by moving the constant off to the side. To complete the square on this quadratic function, we are going to need to set the leading coefficient off to the side. Remember, the leading coefficient must be 1 before making up that magic number. Because we are only working on the right-hand side, we cannot divide by 2. Rather, we factor it out of the variable terms. Once factored out, we can now take half of the middle coefficient and square it. This number gets added in the parentheses. But before we also subtract it, let's make sure of what has been added. What was added is 4 in the parentheses. But look closely. What you've really added is 2 times this due to the factor of 2 outside the parentheses. So to have actually added 8, then you need to also counter it with subtracting 8. Factor the trinomial, add the constants, and you can see the vertex is the point 2, 3, and the axis of symmetry is x equals 2. We finish by looking for the x and y intercepts. The discriminant is negative, therefore there are no x-intercepts. The constant is 11, that's your y-intercept. We now move on to the other method of finding the vertex and the axis of symmetry. To find the formula that will help us in stating this information, we complete the square on the standard form of the quadratic function. What you need to have memorized is x equals -b over 2a. This represents the x-coordinate of the vertex and what we use for the axis of symmetry. Using our last example, let's find this information using what we've just discussed. b is -8 and a is 2. -b over 2a gives us 2. This represents the x-coordinate of the vertex. When you know the x-coordinate and need to find the corresponding y-coordinate, we plug in the x value to find the y-coordinate. Again, the axis of symmetry is always the same as the x-coordinate of the vertex. We finish with an application. An object is fired upward from the ground. This object will reach a max height and then come crashing to the ground. We are being asked for the time it takes to reach the max height and the max height. The function is quadratic with a negative leading coefficient. If it were graphed, you would be graphing height as a function of time. The parabola will open down, therefore there will be a max to this function. We find max or mins by finding the vertex. Negative b over 2a is the 10, therefore it takes 10 seconds to reach the max height. Substituting 10 for x, we find a y-coordinate of 1600 for the max height. Thank you for listening.